Hello and welcome back to another episode of Effective JaRu, the series where we will read effective Java a little bit and see how these techniques apply to Rust. For the most part, this doesn't really work, and we are at one here that definitely doesn't work. And for is the singleton property with a private constructor. So singletons, right? In general, singletons are basically instances that may appear only once in the state of a program. And this makes sense to represent resources which are definitely there only once, right? However, this doesn't work in Rust at all. Not like that, at least. There are singletons, for instance, standard input and standard output, obviously, and in Rust you would get them using IO_std_er functions and IO_std out functions respectively. This will create a new reader or a writer instance, in that case a writer instance, std_out writer that you can then use to do stuff with std_out and std_er respectively. However, I don't know how that is implemented, and I kind of doubt that there is anything global related to it or anything static related to it, because complex static items are difficult to do in Rust for good reason, right? Because suddenly everybody can access these, so it's really like a very shared resource, and you have to put mutexes around them and possibly even arcs to somehow make this work. And yeah, I have not made any good experiences with the attempt to do that, and I think it's also kind of bad practice to have it because singletons can be abused. But anyway, maybe I'm just talking BS here. Let's have a look at these singleton implementations. So yeah, this is new apparently. This is new in Java 7 or 5 maybe, I don't know. At least it was mentioned, I think, as new. So having an enumeration of an Elvis with a single instance of itself, that's how that works. But again, everybody can access this from any thread, and this kind of makes it difficult to do it right? Even here, what happens if two threads are doing the same thing? Will their writes interfere with each other? Will they kind of have partially written lines then from thread 1 and thread 2? I don't know. I think in Rust this is synchronized. And this is even specified in the interface that this is synchronized in the sense that the type you get is implementing sync and send, so you can safely use it across thread boundaries. But here there is no mention of this, so I don't know how that will work. That's one way of doing it. Then the field way. Okay, so we have an Elvis class that has a static field of itself, which is the instance that is created here during, well, program construction, I say. Again, in Rust, this is only working if you don't heap allocate anything, if it's really just simple structures with primitive types or with primitive values in there. Yeah, so usually you then prevent initial or instantiation of that class by making the constructor private, maybe even letting the throw, to protect against reflection attacks, as these are mentioned in the book. So you reflect and then set something enabled, and then you can basically make this call anyway. So reflection is an interesting property of Java that actually, also downcasting, that is actually not supported by Rust at all, which is a bit more difficult to do. You would do it differently, let's say. Your design is definitely affected by these shortcomings in the Rust world. Yeah, so that's one way of doing it. I'm not even executing these because, well, why not? Just even print something up. Wait a moment. Yeah, this is the one. Run main class. Whoa, baby, I'm out of here. All right. Then the method type. So you basically have a static method that accesses a private field. So basically you prohibit accessing the static field that contains the single instance, which allows you to kind of get around or to reserve some more capabilities of change for the future. It's a call, right? And every call, every function call you put in between the client and you basically is a good one, in the sense that you have ways to manipulate what happens then. Yeah, so the same thing here. And here's serializable. That's interesting. Because apparently there are standard ways to serialize and deserialize these Java objects. I have the feeling that this is based on the reflection capabilities of the language itself, which again are not existing in Rust. So in order to get that, you need compiler support or plugins that basically write the code for you that is required to serialize something. This exists, of course, in the Rust world as well. But again, in Rust, you would probably not prevent singletons from being deserialized. You know, basically this says, well, if you're deserialized here, then we don't care somehow. I don't know, read resolve returns an object. I don't know where it gets the object from here. It's not too obvious to me, but again, I don't know anything about it. And apparently this prevents, or this assures that you can just return the standard instance. So this is a final Elvis now. Does it mean it's const? What, you know, Java final, is this const? Is this const? Huh? The keyword final is roughly equivalent to const in C++. Okay, in C++ marking member function const means it may be called on const instances. Java does not have an equivalent to this. Okay. So, values can be assigned once later in Java. Okay, so final int is legal in Java, but in C++. Yeah, but it's the same thing here, right? You assign it only once. Huh. Ah, yeah. In both Java and C++ member variables may be found a const respectively. These need to be given a value by the time an instance of the class is finished being constructed. In Java, they must be set before the constructor has finished. This can be achieved in one of two ways. So you can set it right away, or you can set it in the constructor. In C++, you have to use initialization lists. All right. So what about methods? In Java, final can be used to mark things as non-overridable. Okay. So that's non-overridable. Oh, look. C++ 11 does in fact allow you to mark both classes and member functions as final with identical semantics to the same feature in Java. Whoa! It's amazing. Error in Java, but this is C++ now, is it? No, wait, that's Java. No, sorry. Final comes at the end now. Woo. It doesn't get better, I must say. When I see this, I don't ever want to touch C++ again. Actually, I also don't really want to touch Java, but, you know, gotta do what you gotta do. But C++, you know, I think the only good thing about C++ 11 that is at least sticking in my head is lambdas, easier lambdas, that is, and auto, which is both features you natively and nicely have in Rust anyway. So yeah, interesting. So there is no constness in Java. Is that true? So you can't have constant objects, or what? Can you have a final object or something? Interesting. Huh. That's how I understand it now, but I'm not sure about this, because that would be a major problem, huh? what if I want to prevent stuff from being... Okay, so let's say public static void foo, and it takes a final string args because I don't want this to be changed, right? So what happens now? Let's build this. Cool, that at least still works. And what if I now say, I don't even know how to do this. Args push. Let's open this up in IntelliJ. IM3, this one, right? Maybe I close all of this here. So let's see, because that, this should allow me to see what it can do. So how can I push onto this? Apparently it only shows me the read-only methods, huh? So if I don't make this final, then I have more? No, I don't. How can I push stuff to that then? Hello? Does that work? I don't know how to build there. Call me stupid. Oh, that even works. But it's okay, it's not final. Now it's final. And does it still work? It still works. I don't know. I may call this final, but it has no effect. Okay, so there seems to be no const variables, huh? Const object Java. Doesn't work. It says should not be reassigned, blah, blah, blah. Just make it immutable. Okay. Or wrap it in another object which restricts access to mutators of the object in question. Unmodifiable list. Okay, shit. So it's all at runtime, huh? There's no compile time immutability. There are constants that may be assigned only once, but there's no access. Ooh! How can you write anything in a language like that? Even C++ is better in that regard when it comes to that kind of safety, isn't it? Sorry, I don't get that. I don't understand that. Phew. Terrible. Let's check that out. And I wonder, do I want to try anything in Rust in that realm? Singleton stuff? No, but I would like to have a look at the source and try to find the implementation of stdout, because I want to see how this is implemented. So that's how a singleton is done here, huh? So that's a static. Okay. Lazy reentrant mutex ref cell line writer maybe stdout raw. Whoa, stdout init reentrant mutex. Where is that coming from? Is that a standard? Syscommon remutex reentrant mutex. So that is interesting. I've never done a singleton in Rust, but here you see it. Return. Okay, so here you just wrap it into a new object. And this is this just called once? Well, what's the semantics of this? Yeah, I would like to know that. You need a lot of protection there to make this work. Lazy. Okay, what's lazy then? IO lazy. Is this something public? Because lazy semantics, they can be useful for anybody, but it doesn't seem to be part of the public interface at all. So this lazy probably means that it is evaluated only later. Ah, here's the std init function that is what? That is provided here. Ah, so this probably means that on first access, call this function, and then you get an arg mutex buff reader, maybe std in raw, and this std in raw is a type, a new type that has an std in item in there, and we can call it, we can ask for it, and then we just instantiate a new one, it seems. Yeah, so it seems we do instantiate multiple items of that kind. Maybe real std in, maybe fake. Ah, so that's kind of an optional here, huh? So instead of some and none, it says maybe real. So we have a raw one, we do this, otherwise we put a fake there. The default buffer capacity is 64K, but apparently Windows doesn't like 64K to read on std in. Windows, there's a smaller buffer. Oh, look at that. That's compile time condition? It's like a static if? Oh, no, wait, probably it is not a static if. This is a macro here. And I'm pretty sure that this, you know, even though the compiler might see that this is always true, and then I think this is how it goes. This evaluates to some Boolean, a Boolean value, and then the compiler will just prune out the inaccessible branches here of that condition. I think that's how it will be. So you have a buff reader which possibly has a fake in there, huh? But this maybe must probably implement right, yeah, here it is. Okay. So if it has a real one, it does the real thing. If there's a fake, it just returns standard values. That's really interesting. Still. Yeah, this lazy thing, I think it must be. Yeah, maybe find a file that implements it. Lazy, here it is. Haha. It has a lock, it has a pointer. Okay, so that is unsafe special stuff. An init function. So instance get interesting. Interesting. So it locks every access. And then, wow, that's above me though. This is unsafe code, right? And usually you don't want to see that because then it gets nasty. After all the Rust stuff is built on unsafe code after all. Yeah. So I must say, I you know, can only shake my head here and say, well, constant complex statics or singletons you will not have. And personally, I do not mind that. At the end of the day, you will find it easier to not enforce a singleton, but instead to just have a instance of something that you use as a singleton. And you know, it makes testing easier as well, I think. So I'd say it's a good thing not to have it. And if you really wanted to have it in Rust, it's not easy. As usual, if it's not good things, then it's usually hard to achieve in Rust. stdin lock. Yeah, but that's an optional thing, huh? Yeah, you can lock the... I don't know if you also have a lock on the output, but probably not. But I thought this was synchronized, because there is a mutex protecting this thing here, right? And again, I have no idea why that works. Because here, even though this is static, you do a get on this. I mean... we can probably have a static counter that works in Rust as well. I would wonder if this is evaluated just once here. Yeah. But this lazy kind of indicates that it's supposed to be lazy. And, you know, if you call get here right away, then it would initialize it right in the next line. And this is something I don't get. Why all the lazy stuff here if it can't be lazy, really? I don't know. Yeah, so this lazy, it puts an arc around the type T here, so that's why you don't have to specify arc here, even though inner is an arc mutex buff reader of maybe an stdin raw. Yeah, that's interesting. Maybe that stdin raw handling has also to do with the fact that sometimes you don't have access to stdin because maybe it's actually not there, and you want to kind of work around that possibility and just make it kind of a null reader or null writer. I think this is what happened, huh? What happens here? Yeah, interesting. Let's have a look at the documentation for static items, mutable statics. A static item is similar to a constant except that it represents a precise memory location in the program. A static is never inlined at the usage side, and all references to it refer to the same memory location. Static items have the static lifetime, which outlives all other lifetimes in a Rust program. Static items may be placed in read-only memory if they do not contain any interior mutability. Statics may contain interior mutability through the unsafe cell. Aha! There we go. But it's still difficult to instantiate it, at least on module level, right? Do we have a cell here? No. But a mutex. Wow. All access to a static is safe, but there are a number of restrictions on statics. Statics may not contain any destructors. So you can't basically use lots of the items that allocate memory. Like, yeah, pretty much a lot. The types of static values must ascribe to sync to allow thread safe access. Statics may not refer to other statics by value, only by reference. Okay. Constants cannot refer to statics. Constants should in general be preferred over statics unless large amounts of data are being stored or single address and mutability properties are required. Single address and mutability properties are required. Mutable statics. If a static item is declared with the mut keyword, then it is allowed to be modified by the program. One of Rust's goals is to make concurrency bugs hard to run into, and this is obviously a very large source of race conditions and other bugs. For this reason, an unsafe block is required when either reading or writing a mutable static variable. Care should be taken to ensure that modifications to a mutable statics are safe with respect to other threads running the same process. Multiple statics are still very useful, however, they can be used with C libraries and can also be bound from C libraries in an extern block. So here we have a static mud. Oh, that's how you specify it, okay. Static mud levels U32. This violates the idea of no shared state, and this does internally protect against races, so this function is unsafe. True, but you could possibly wrap this into a, well, you could make this atomic, right? Then it would be fine again. Yeah. Assuming that we have an atomic add function which returns the old value, this function is safe, but the meaning of the return value may not be what callers expect, so it's still marked as unsafe. Okay, mutable statics have the same restrictions as normal statics, except that the type of the value is not required to ascribe to sync. Okay. Very interesting. Huh. Thread safe access, so sync needs to be there. Alright, that's statics. But yeah, hard to do singletons that way. I still don't know how that responds here, and if that really is, I mean, there must be only one memory location then, right? This is what we have just read. So there's just one of these, and we use the same memory location to maybe reinitialize it or something? Is this what happens here? Is this a new thing then? I don't know. And you know what? I don't want to find out right now. Oh. Which one? Maybe this one. Okay, so I seem to have a dead project in my project list. Yeah, I'm not going to do this. No singleton and Rust. It's not easy. Let's call it the word of the day. Thanks for watching and have a great day.